We're going to talk about exposure. So exposure is the amount of light recorded by the camera. So in this example here, the f2.8 is on the bright side and f22 is on the dark side. We think of too much light as being closer to white. You don't have a lot of detail in your highlights. Things are overexposed, and that's what we like to call it. If we call it underexposed, we think about having too little light, and we have areas of shadow, especially that are deep and dark, no detail. So here's some things that help us play with exposure. So your shutter is the thing that opens to allow light to hit your sensor. And when the shutter opens, it opens for a certain amount of time. So shutter speeds are that amount of time. Aperture is the size of a hole. So in your lens, f22 is a very small hole and f2.8 is a very large hole. The stop refers to a change in exposure. It can be either aperture or shutter. It's just a change in the amount of light being recorded. Whereas f-stop, we typically think of with apertures. So one stop more exposure means you're doubling the light. So if you started at f4 and you go to f2.8, you've doubled the amount of light. You've added a stop of light. Or if you're at f4 and you go to 5.6, you've gone one stop less light, or you've halved that amount of light entering the camera. So if we think about it, besides those tools, these are all the things that affect exposure. So we have aperture size, shutter speed, film speeds. On film cameras, we just kind of really think of this as ISO, as light sensitivity, if you will, in digital cameras, and the amount of available light. So it's this combination that helps us determine how much light's actually recorded. So you can kind of think of exposure as filling up a bucket of water and light being the water. So the longer you have the water going in the bucket, the more full the bucket's going to get. So the longer the shutter speed, the more light that's going to enter your camera bucket, for lack of a better term. And if you had a faucet with a big opening, you fill that bucket faster at the same amount of time. If you have a faucet with a small opening, you fill it not as much in that same amount of time. So here's our little cheat sheet that I give out in class, and it kind of shows you all the things that are part of the relationship here. So ISOs are the sensitivity your camera has to light, and you can kind of see that if you want to have more light entering your camera, you go to 3200, so it's more sensitive. And then if you want less, you'd be closer to 50, so less light entering your camera. So kind of think of that to some degree there. Now, aperture is going to be so that if you have f1.8, more light's going to be entering your camera, and f22, less light's going to be entering your camera. And at shutter speed, at 1 second, you're going to have more light entering your camera, and at 1/1000th of a second, you're going to have less light entering your camera. So that gives you kind of the exposure factor, but you can see there's other things that are affected as well. So ISO, the sensitivity to light. So ISO is going to change depending on your lighting conditions. So you can kind of see here some recommendations and how it's going to affect what aperture choices or shutter speed choices you have if you had a set ISO of 100, for example, here. It limits your range to some degree. So we have a lot of different ISOs. So you can actually do exposure without a light meter, though a light meter helps us when we have a different PowerPoint on light meters. So this is kind of what we call the Sunny 16 rule, and how you do things at f16 as kind of a starting point. And it gives you an idea that if you were to shoot in a bright sunny situation at f16, and you do that at 1/250th of a second, you would get that to be a decent exposure, and then you can kind of adjust everything based on that. There's a couple notes as far as things like backlit and things like that, so you'd have to adjust this a little bit, so it's saying like basically if it's super bright, you'd have to go to 22. If it's cloudy, you'd have to go to 8. If it was very overcast, 5.6, and then open shade, 5.6. So you can kind of change this around, but it gives you kind of an idea here and how to play around with this. I don't do that too much in class, but just gives you an idea. So a little bit of light meters here. We have two types of light meters. Reflected light meters, that's like what's built into your camera. So if you look at kind of the bottom of this diagram, if you look in the middle of this diagram, you can see the built-in meter. So sun hits the person's face, bounces off the face, and goes into the camera. So that's kind of what you're used to. Incident means it measures the actual light that falls onto the subject. It is more accurate. So a handheld light meter is able to tell you exactly how much light is falling into that place because it's falling directly on the light meter itself. But your camera light meters are pretty darn good. So we're going to look a little bit about metering modes, and that's going to help us just a little bit with determining a little bit about exposure. So we'll use different metering modes with different types of light situations, but I'll go into this more in a different PowerPoint presentation. Now, we talk about a gray card, and why we talk about a gray card is this: when your light meter is working, it's looking at the exposure of the light levels based off of 18% gray, so in this neutral gray. So it doesn't see the parrot, it sees 18% gray, and then it's telling your light meter basically it's either brighter or darker than 18% gray, and it's making adjustments accordingly, especially if it's set up in kind of an automatic mode. So if we put this all together, it kind of gives you an idea of how these kind of work together here. We're going to do some scenarios in class about this. Again, your exposure cheat sheet helps you a lot. I put this up here just to show you there's a thing called equivalent exposures, and this shows you that you can have the same amount of light entering the camera with different aperture shutter speed combinations. And based on those aperture shutter speed combinations, you're going to end up with a different aesthetic or different effects. So these three images are the same amount of light entering the camera. The one on the left has a slow shutter speed, and just you holding a camera might end up with a blurrier picture. The one on the right uses a faster shutter speed, but it uses a wider open aperture, a 2.8 aperture in this case here, and that has a shallower depth of field, which is blurring the background more. So you may like that one, or you may like something in between. So you have these different combinations. So this kind of shows the equivalent exposures some more. So you can kind of see when you have a slow shutter speed such as 1/8 of a second, and you have f16, a small hole, if you want the same amount of light entering the camera, you'd have to make these changes per each stop. So as we go to f11, more light enters the camera on a bigger hole, so we can't keep the shutter open as long. And then as you go to f8, again, you have to go with a faster shutter to 5.6, a faster shutter, and so on. And these are our whole stop apertures, so they're one stop difference. So one stop difference between f16 and f11, or 1/8 and 1/15. So we'll use terminology when we talk about this. So we can say things like f8 lets in twice as much light as f11. It is one stop more light than f11. Or we can say f11 is half as much light as f8. It is one stop less light than f8. So we can do the same thing with shutter speeds. 1/60th lets in twice as much light as 1/125th. 1/25th is half as much light as 1/60th. So here's another example of equivalent exposures. So the car is actually moving. It's a wind-up car and it's moving. And at 1/250th of a second, we have that stop action look. But the people in the background at f4 are kind of blurred out with shallow depth of field. Now as we get to 1/8 of a second, the car is blurry, but we have more depth of field at f22, so we have more foreground, middle ground, background, and focus. So you can really see that in the pigeons. So at 1/125th of a second, blurry pigeons at f4, equivalent exposure at 1/500th of a second at f2. We have pigeon wings pretty much stop action, but if you look at the trees in the background, they're very blurry because of shallow depth of field. bracketing is where we don't have equivalent exposures. We purposely let in a little more light, a little more dark. So instead of changing both aperture and shutter speed, you just change one. So in this example, we're using 1/60th the shutter speed all the way through, but we're changing the aperture. So if we have the center one being 1/60th at 5.6, the one on the left, which is brighter, would be 1/60th at f4, and the one on the right, which is darker, would be 1/60th at f8. And that can kind of show you the differences in bracketing, so you get a range of exposures. Here's a little bit more extreme. There are 2 stops in each direction. So metered exposure in the middle, 2 stops overexposed on the right, 2 stops underexposed on the left. Personally, I think probably the right amount of exposure is probably in between the metered and the 2 stops underexposed. So maybe 1 stop underexposed might have been the best way to go. So bracketing, if you do that, you might be able to catch that ability and have more options. So as you can see here, we put all these tools together and figure out what exposure we think is going to serve us best.